Welcome back. So now let's start solving the circuits by using the Thevenin theorem. Okay. So for example, we have a circuit and we want to calculate the V naught, the voltage drop across 1 kilo ohm using the Thevenin theorem. Okay. So the Thevenin theorem constitutes of two things. Okay. Like we need to calculate the open circuit voltage and the Thevenin resistance. So once we have that, then we can use that to compute the Thevenin equivalent circuit to get our desired output. Okay, so let's do that. So first step is always, okay, the branch, the resistance or the network where you want to calculate actual your desired voltage or current, we will take that and place it outside of our circuit. So I will take this 1 kilo ohm and I will just place it outside of my circuit. Okay, so I want to calculate basically the voltage drop here. So the Thevenin equivalent circuit will be, I need to get equivalent Thevenin resistance and the open circuit voltage, which will be basically V Thevenin. Okay, so this is the first step. Second is, and after that draw the circuit. Okay, once you remove that, so if we redraw our circuit, it will look like this. Remove means like we are making the branches open circuit at that point. Okay, so here actually that was connected. Okay, so this is 12 volt, this is 6 kilo, this is 6 kilo, this is 2 kilo. Okay, so now from this open circuit point we need to calculate, like if I look from this end of the circuit, what is the equivalent resistance, or we call that Thevenin resistance, or what is the voltage drop between these two nodes. Okay, that will be called as basically V Thevenin or open circuit voltage. Okay, now the second step is, let's calculate the Thevenin resistance. Okay, now to get the Thevenin resistance, what we have to do, okay, we need to put focus on this circuit. So I want to calculate the Thevenin resistance from this circuit, so we will remove the any source in our circuit. So if we have a voltage source, okay, we will make it short circuit. Okay, if we have a current source, we will make it open circuit. Remember, this is to calculate the equivalent resistance. Okay, so let's apply this thing here. So we have a voltage source here, so what will I do? I will just make it short circuit at that point and I will redraw the rest of the circuit. So the rest of the circuit will look like this one. Okay, so this is 2k, this is 6k, and this is 6k, and we want to calculate the R Thevenin from this end. Okay, so now how this will look like? So we will apply the same principle of series parallel resistor combination that we have learned earlier on. So we will start from the end of the circuit, that I want to calculate the Thevenin from between these two. So end of the circuit, I have 6k and 6k. So this is basically sharing two nodes. So basically 6k and 6k parallel. So 6k parallel with 6k, that will give me what? 3k. Okay, so it means I can redraw my circuit with the 3k, and then I have this 2k here, and this is my measurement point. Okay, R Thevenin. Now if I look at this circuit, so this 3k and 2k, they are in series. So basically R Thevenin will be 5 kilo ohm. So I get basically this value of 5 kilo. Okay, so third step is calculate the Thevenin voltage. Okay, so now let's calculate that. For the Thevenin voltage, we will come back to our original circuit here. So we want to compute basically the voltage drop between these two nodes, right? So if you look at this circuit, now here like you can use whichever technique. For example, simple KVL, simple like voltage divider rule, current divider rule. If the circuit is complex, you can use source transformation, nodal mesh, whichever technique. Our target is to find the voltage drop here. But if I look at this circuit is very simple. For example, we know that we have an open circuit branch here, so no current will be flowing through this 2 kilo ohm. So it means the voltage drop across 2 kilo ohm will be 0. So I can redraw this circuit again like this. Like this is basically 0. Okay, so it means I am here basically, the point where I want to find the voltage. So this is 6K, this is 6K, this is 12 volt. So it means the voltage drop between these two nodes is the same, that is a voltage drop across this 6 kilo ohm, right? Because they are in parallel. Okay, so if we find the voltage drop across this 6 kilo ohm, that will be the same voltage drop. So simple series circuit, we can apply the voltage divider rule. So this resistor divided by total resistance 6 plus 6 multiply with the supply voltage, that is 12. So it will comes out to be 6 volt. Or directly we can find if this is a 12 volt, so 6K, 6K, same resistance. So 6 volt will be here, 6 volt will be here. So we got our Thevenin voltage. So we will put that Thevenin voltage here. So this completes our Thevenin equivalent circuit. Remember, we can switch these steps. Like I can calculate V Thevenin first, I can calculate R Thevenin later on. Okay, like 2 and 3 can be done as per your like. Okay, but like once you get those, you need to put up those in the Thevenin equivalent circuit. So we have our Thevenin equivalent circuit. Now it's fourth step. Fourth step means calculate your actual desired voltage or currents that we want. In our case, we want to find V naught, which is voltage drop here. So we have very simple circuit. Simply we can apply the voltage divider. So this resistor 1K divided by the total resistance 1 plus 5 multiply with the supply voltage, which is 6. So basically 6 divided by 6, it comes out to be 1 volt. So this is the output voltage across 1 kilo ohm, which comes out to be 1 volt. So this is a way to apply the Thevenin theorem to solve the different kind of linear circuits. Thank you so much.